Okay, so the calculation for pH of an acidic salt. So let's go with a 0.10 molar ammonium chloride. So the chloride ion is neutral. The ammonium ion is acidic. So if we write out its acidic reaction, it's going to form a weak base and H3O plus. And that's because an acid is an H plus donor, correct? So it's going to donate it to water. Okay, so the pH is going to be determined by the strong acid, which is the H3O plus, synonymous with H plus, strong acid. And then the NH3 is our weak base, but who's going to dominate is the pH, is the H3O plus. That's going to dominate it. So we can set up our ice chart again. Now you realize why it's so important for us to have learned our ice charts. And then this is now the acidic species, so we're going to need Ka. If you look in the back of your book for the Ka, it's not there for ammonium ion. So you have to look up the Kb for ammonia. That is in the back of your book. That's 1.8 times 10 to the minus 5. Ka times Kb equals Kw. So if we solve for Ka, that's going to be 5.6 times 10 to the negative 10. And we would plug that number into here. So we could say 5.6 times 10 to the negative 10 equals x squared over 0.10 minus x. X is very, very small because the Ka is super small. And then when we solve for x, we get 7.6 times 10 to the, let me make sure on that. I feel like I've done this a lot with the same numbers, but. Oh, so yeah, 7.5 times 10 to the negative 6. And notice that that x is H plus or H3O plus. So we can plug right in to negative log of that number. And we get 5.12. So notice that we will set this up just like any other weak acid problem. The only difference is that you have to find the Ka through this extra calculation here. But other than that, it's a simple weak acid problem.